Okay, so today we're going to talk about the ideal gas law, and we're going to do a problem involving hydrogen and determining the pressure that it produces under certain conditions. So the ideal gas law assumes that the particles are so small that they don't interact. And when I say particles, I mean like the atoms or molecules we're looking at. So, the ideal gas law. So, because they don't interact, we get a very simple equation that we can use to help describe their behavior. And that equation is PV equals nRT. Now, when we look through this, our P represents our pressure, V is our volume, N equals the number of moles of whatever particle you're talking about. R is a constant, and the constant can vary depending on the units. So that you can use different units in this equation. It's still easy. And T is our temperature. And our temperature, we have to be very careful because we have to have it in units of Kelvin or Rankine. And usually you'll use Kelvin if you're using the SI unit system. So for our problem, we want to know the pressure that we're going to get in a container when we have 5 liters for our container. We have it at 500 Kelvin, and we have 3 moles of hydrogen in that container. So, first we need to decide what value of R we're going to use. So we need to look at our units here. So we have liters, Kelvin, and moles, right? And they want us to give our pressure in atmospheres. So we want the pressure equals in atmospheres. So looking through the constants, you can find these in log tables. The constant we're going to use today is 0.08206 liters atmospheres per mole Kelvin. You can see we've incorporated all of our units here, so it should make them cancel out. So, now we're going to substitute what we know into the ideal gas equation. So we have PV equals nRT is our equation. We said we don't know our pressure, so we'll just leave that as P as the variable. Our volume, we said, was 5 liters. It's going to equal the number of moles, which we said was 3 moles, times R, which is our constant, 0.08206 liters atmospheres per mole Kelvin. And then that's multiplied by our temperature, which is the 500 Kelvin. Now we're going to look through this and we're going to simplify it. And first we're going to cancel out our units. So we can see kelvins will cancel here. We can see our moles will cancel here. So now we can do the multiplication. So we have 3 times 0.08206 times 500. And that's going to give us 123.09. And the units we have left is just liters atmospheres. Right? And that's still just going to be equal to P times 5 liters. So now we want to get P by itself, so we're going to divide everything by the 5 liters. So P then is equal to 123.09 liters atmospheres divided by 5 liters. When you do that math, you get 24.618 atmospheres, because your liters will cancel because you're dividing it. So this is the ideal gas law.